Okay, trapezoidal rule. We want to approximate the area under the curve using the given interval 1 to 5 and using 4 trapezoids. Well, we need to write it as an integral, and if we do that, we'll probably understand a little bit better. So we're going to put the values of 1 to 5 here, and the function in this problem is area under the curve, which is y is equal to x squared plus 1. So we can enter x squared plus 1, okay? And that's d of x. Now, what you need to understand is that the trapezoidal rule is a formula, and the formula is delta x over 2 times all this here, okay? Which the x0, x1, x2 are inputs between the intervals that are given. In this case, x0 would be 1 all the way to 5, and 5 would be your xn. Okay, so we have to follow this formula here to be able to find the area under the curve using trapezoidal rule. Now, it's an approximated value that you're going to get here. Now, the interval gives you a defined value. So if we took the integral or the antiderivative of x squared plus 1, and we figured out the interval in that fashion, we would get an exact value. But here we're trying to get an approximated value by using a trapezoidal rule. And so to be able to use this trapezoidal rule, we need to understand what delta of x is. Delta x is defined by b minus a over n. N is the actual sections that you're going to use in terms of what kind of objects you're going to have from in between that interval there. So we're looking from 1 all the way to 5 here, trying to find the area under that curve, okay? But we're gonna cut it up into 4 sections, which is going to be from 0 to 2, from 2 to 3, and from 3 to 4, and then from 4 to 5. Visually, you can see it here, and if we place a trapezoid here, trapezoid there, trapezoid there, trapezoid there, and we found the area under of those trapezoids, that would give us this formula here. So this formula is the sum of the area of the trapezoids in these 4 locations. So n is the number of trapezoids that you're using. Okay, so delta x is going to be 5 minus 1, right? That's b minus a, 5 minus 1, over how many sections? Well, 4 trapezoids, so that's 1, 2, 3, 4 in these 4 locations. So it's going to be 4 over 4. Okay, a lot of times delta x is going to be 1. But we need to make sure, because we could have done 2 trapezoids, which would make it a lesser approximation. So we want to try to get to the closest approximation. So we want to make this delta x 1 or even smaller than that. But a lot of times it is 1. So in this case it is 1. So now we plug in the values into this formula here. We're not going to find the integral because that would give you an exact value of the area under the curve. But approximated area under the curve using trapezoidal rule would have us using this formula here. So we're going to pay attention to this formula, and so we're going to work it out here, down here, and so we're going to plug in the value. Delta x is 1 over 2. Okay, now f of 0, this is your f of x here, which we see it underneath the curve, right? The curve is f of x. So if we plug in f of x0, x0 is the first value from our interval value, which is 1. So we're going to plug in f of 1, and then we're going to plug in 2 times f of 2. We're going to continue it all the way to the end of the interval. So we always multiply after the first one by 2, f of 3, and then we multiply 2 times f of 4, But then 5 is our last value of n. So in the formula, we don't have a multiple of 2 for the final, so we don't have to multiply by 2. We don't multiply by 2 to the last part of the interval. Okay? So that's our formula there. So now what do? We substitute the function in place of the f, and so the input is 1. So that's going to lead us to what? 1 squared plus 1 for the first part, and then plus 2 times 2 squared plus 1. So I'm making it more visual for you. I'm inputting the value into the function itself here. And then we have 2 times, again, 3 squared plus 1. And then 2 parentheses 4 squared plus 1, following the function and the inputs. And then the final one doesn't have a 2 up in front, so we do 5 squared plus 1. Okay. Then we continue by assessing this, and we get 1/2, and then 2 squared is 4 plus 1 is 5. 2 squared is, sorry. Now, 1 squared is 1 plus 1 is 2. And then we continue. 2 squared is 4 plus 1 is 5. 5 times 2 is 10. And then we continue. 3 squared is 9. 9 plus 1 is 10. 10 times 2 is 20. 4 squared is 16 plus 1 is 17. 17 times 2 is 34. 5 squared is 25 plus 1 is 26. We add these, and we find out that 26 plus 34 is 60. 60 plus 20 is 80. 80 plus 10 plus 12 is 92. Okay? And then 92 times 1/2 is the same thing as dividing 92 by 2, which is 46. And we're trying to find the area under the curve, so that's square units. So our answer is 46 square units. And that's how you use the trapezoidal rule.